Hello everyone. Today we will start talking about measurement uncertainty, and it's the last lesson in chapter 8, section D. Okay, in that lesson we will revise some aspects or some um, concepts of uncertainty in general. When we use apparatus in the experiment, we will obtain a value. That value contains inside its amount uncertainty. It means in a doubt of my value. Okay, this uncertainty comes from what? Comes from calibration and manufacturing of my apparatus. So this apparatus contains somehow error, and that error will give me uncertainty and a scale of uncertainty in my value. Okay, but the uncertainty, it's not fixed according to the apparatus we are using. It's different according to the values we are measuring. Okay, so instead of using measurement uncertainty all the time, we use percentage uncertainty. What's the meaning of percentage uncertainty? It's the actual measurement uncertainty. So it's the real uncertainty in the experiment, and it's multiplied by 100. Why? Because it's a percentage, and it will be divided by my recorded value or the obtained value from the experiment. So what are the tools or the apparatus we use in the lab, and those tools will give us uncertainties in their values. Let's start with glassware. Okay, in glassware we will see the burette. In general, the capacity of a typical burette in the lab is 50 centimeter cubed. Okay, so and also, the smallest digit you can read from the burette, it's up to 1 decimal place. Okay, so the decimal place here, it's 0.1. It means we can read up to 1 decimal place from the burette. In order to calculate the uncertainty for a reading from the burette, I will take this smallest digit and I will take the half of it. So the half of 0.1, it's 0.05. So all the time to calculate the measurement uncertainty for any burette or any tool, you look at the smallest digit you can read, and you divide it by 2. Okay, in order to calculate the half of that smallest digit, then you obtain your uncertainty. Okay, in order to calculate the percentage uncertainty in the burette, it's what? It's my measurement uncertainty I obtain in the experiment multiplied by 100, okay, and divided by the recorded value you got from your burette. Okay, here we can see we have multiplied this percentage uncertainty by 2. Why? Because we repeat the procedure in order to get the volume 2 times. In order to read any volume from the burette, I will read the initial volume, then the final volume, then I will subtract them. Okay, by subtracting those two values, I will get my volume. Okay, so in order to read the volume, I will use the burette 2 times. So 2 times 2 readings, it means 2 uncertainties. So you have to multiply the percentage uncertainty by 2. Okay, so each tool has a different case. In the burette, all the time, in order to read any volume, you use it 2 times in order to record the initial volume, then the final volume, then you subtract 2 volumes from each other. So you are reading the burette 2 times, so you have to multiply the uncertainty by 2. Okay, Let's go for the pipette. In the pipette, the capacity for typical pipette, it's 25 centimeter cubed. The uncertainty, let's assume it according to pipette decimal places, it's plus minus 0.06. Okay, this is according to the smallest digit you can read from your pipette. In order to read the pipette volume, you read it only once. Okay, so the uncertainty, it will be only plus minus the measurement uncertainty multiplied by 100 and divided by your recorded volume or value. Okay, let's go for the last glassware. The last glassware, it's what? The volumetric flask. Volumetric flask, the capacity, let's assume it's 250 centimeter cubed, and your measurement uncertainty according to the smallest decimal places in it, it's plus minus 0.3. So the percentage uncertainty, it's the measurement or the actual measurement uncertainty multiplied by 100 and divided by your recorded value. Okay, this is for the glassware. We also use in the lab the balance in order to weigh the mass. So the percentage uncertainty, before we start calculating it, we have to show or to represent what are the factors, or the percentage uncertainty of a balance depends on what? It depends first of all on the precision of the balance. Okay, and the precision of the balance, it means what? It means how many decimal place this balance can read. Okay, how many decimal place this balance can read for each mass. Some balances can read for 1 decimal place. Other balances can read for 2 decimal places. So this is the precision of your balance. Number 2, the mass you are weighing. The greater mass you are weighing, the less uncertainty you will face. Okay, so greater mass, less certainty. Less mass, more uncertainty. Sorry, it's uncertainty. Okay, so greater mass, less uncertainty I will face. Example. In that example, he asks you to calculate the uncertainty for that value, and that value, it's mass. It's 3.57 grams. How can I calculate the uncertainty for that mass? Percentage uncertainty, it equals what? The measurement uncertainty. How can I calculate the measurement uncertainty of that balance? It's what? It's the smallest digit we have divided by 2. We have here 2 decimal places. So the smallest digit, it's 0.01, and divided by 2, it's what? 0.005. This is the measurement uncertainty. Okay, I will use it as plus minus 0.005 times 100 divided by what? Divided by your recorded value, it's 3.57. But guys, in order to read a mass, we have to tear your balance. Tearing the balance, it means we will set it at 0. So setting the balance at 0, I will use it for the first time, then I will use it to measure my mass. So I will use it 2 times. So the percentage uncertainty here must be multiplied by 2. Okay, here the final value for that percentage uncertainty, it's what? 0.28%. It means the uncertainty of that balance, it's 0.28%, and it's plus minus. Okay, now let's take another example. In that example, we have that mass. We use a balance in order to weigh a mass of a solid. I put the solid in a weighing bottle, then I measure it with the solid, and we got this value. It's 20.354 grams. Before that, we weighed the bottle when it was empty. It was 19.816 grams. In order to calculate the mass, I will subtract these values from each other, and it will give me 0.538 grams. Okay, this is the mass of a solid. Calculate the percentage uncertainty for that value. We can see here we have 1, 2, 3 decimal places. The half of it, it's 0.000 and what? And also other 5. Why? Because the smallest digit, it's what? 0.001, and we divide it by 2 in order to calculate the measurement uncertainty. This value, I will multiply it by 100 over what? My recorded value. But each time we we weigh the mass, we have to calibrate or to tear your balance. Then you measure the mass. So the uncertainty here, it's multiplied by 2, and the uncertainty here will be multiplied by 2. So we have 2 and 2. So the overall percentage uncertainty for that balance, it's 4 times that value. Okay, let's go for experiment or example number 3. If we have an experiment like titration, and we use titration in general to find the concentration of a solution, assume a titration give me the concentration for a solution. It's 0.118 mole per decimeter cubed, and he asked me to calculate the overall percentage uncertainty. In general, in the titration, we use balance, we use volumetric flask, we use pipette, and we use burette. Okay, all of these tools are used, and each one has a specific uncertainty. So I will calculate it as usual, like the previous method. For the balance, I will calculate the percentage uncertainty by multiplying 2 times the measurement uncertainty of that balance. How many decimal places do we have? Divided by 2. This is the measurement uncertainty. And we multiply it by 100 over what? The recorded value you use it in order to measure the mass. Okay, so each tool you will calculate for it what? The percentage uncertainty. After that, you sum up all of these values together, and you obtain the overall percentage uncertainty. He asked me what is the measurement uncertainty for that value. I will put it inside the equation. In general, the percentage uncertainty, it equals what? It equals the measurement uncertainty multiplied by 100 over the recorded value. It's my concentration. By doing cross multiplication, I can find that the percentage uncertainty of that concentration, it's plus minus 0.001. Okay, now how can I reduce uncertainty inside any experiment? I have to look for the type of the experiment. If the experiment was thermal experiment, I need to decrease any heat loss. Okay, by decreasing this aspect or concept, I'm going to decrease anything will give me a random error. Okay, also if we have a titration, we must be concerned about volume and masses, and use accurate methods in order to record these values. Step number 2, or point number 2, we can use, or we can deal with greater volumes and greater masses. Each time you get a greater volume, it means you will get lesser uncertainty in your record and value. That's it for lesson 6. I hope you understand all of the points, and I will wait for your questions, and see you in the next video. Thank you.